Hello, yes. So emerging identifier technologies. Um, well, this is an ICANN expression for anything that is about naming systems that are not DNS. Something that is coming up new and is not DNS. And so today, I would like to talk about blockchains because the blockchain naming systems are somehow becoming very popular in the latest time. And so they have come up on ICANN's radar, and I think everybody else has heard about them too. So let's have a look. And in the last months, ICANN has published two documents. One describes blockchain technologies in general, and the other one describes blockchain naming systems. Um, and they are described in a very neutral way. So you get an introduction to the technology, and there's absolutely no, um, you know, uh, we don't tell you if this technology is good or not, or if it has a future or not. That is absolutely up to you to decide. We have no insight into that. And so, so blockchain technology is what is that? So, and obviously the blockchain, you've probably heard this, is a ledger. And what is a ledger? Well, in your company, you would call this accounting, bookkeeping. You know, 20 coins in, 5 coins out, stuff like that. That's a basic bookkeeping. And in the blockchain, what you do is you have these transactions, they are called coins in, coins out, and you batch them together in a block, a lot of these transactions together, and you compute a little bit, and then you have blocks, and that's a blockchain. Um, Something that a lot of people find very, let's say, surprising is that the blockchain doesn't keep a balance. So if you have bookkeeping in your company, accounting, you usually have, coins in, coins out, but at the end, you always have a balance. You always say, oh, I have to have this much money in my bank account, or I have to this much money in somewhere. And then you can check your bank account to your bookkeeping, and you can say, yeah, that's right, or that's not right. But you do it all the time. Uh, you don't do that on a blockchain. On a blockchain, you record all the transactions, but you don't record the balance. To get a balance and to be able to decide if the next transaction can transfer coins from one account to the other, you actually have to run all the transactions from the blockchain, record the result in a database, and then check in your database, does this account have enough money to make this transaction? And so this is, for most people, find this very surprising, at least. Um, I know that it was for me when I heard this the first time. And then you have many blockchains that have something that is called, the transaction can not only be coins in, coins out, it can actually be a program that you can run. They're usually called smart contracts. You could discuss how smart they are, but they are called smart contracts. And the smart contract usually results in one or more transaction on the blockchain, but you don't record the transaction in the blockchain. You record that this program has to be run. And then again, if you want to know the balance in the end, you have to run this program, and it will result in some changes in your database. So these blockchains, they have models of trust, and they are very different. Uh, Usually they are called decentralized because there's no central entity that controls anything. There's a lot of parties all over the world that participate in the blockchain, and they don't have to trust each other. They have some way of to agree on what the blockchain would be, and so it's a very well, that's what they call decentralized, at least. So you have these people agreeing over the internet, and so but this can be very, very different. So You probably have heard of the, let's say, uh, proof of work type block. For example, Bitcoin works on proof of work. You have to do a lot of computation for the next block. And so you need so much computation that even for after some time, it would be even prohibitive for a government to falsify the blockchain because they just can't get enough computing power in time to to change the blockchain. And then you have a different model that is called proof of stake, where people actually put up their own money against transactions. So you would say, oh, I guarantee that this transaction is legitimate. And to guarantee this, I put up so much money of my own money to guarantee this transaction. And then if everybody agrees on this, then you saved your money and you probably get some reward. But if everybody says, well, you're trying to fraud us, then you lose your money. And so there's a different type of building trust and building consent. And so the first one, the proof of work, has come to critics that it uses a lot of energy. And so that is why a lot of blockchains have switched to the proof of stake model, because it uses a lot less energy. And then you have layer one blockchains that you have probably heard of, like Bitcoin or Ethereum. There's a lot of those blockchains, not only those two. And then you have a layer two, which is also a blockchain, but it's usually a lot faster, and only at certain intervals are the results brought back to the main chain. And usually this is done because the transactions on the main chain are slow, and transactions on the main chain can be very expensive. I mean, for example, for some time on Ethereum, a transaction on Ethereum could cost you like $100. So if you wanted to register a Ethereum name for $5, you would have to pay $100 to get your $5 transaction recorded on the blockchain, which is like, not very sensible. And that's why you often have some side chain, these layer two chains. And then you have side chains that are something like layer two, but they have a special purpose and record only these special things. So example, you could have that for a name. So, and then obviously in all of this for blockchain, there's a lot of cryptography involved, but blockchains usually use standard cryptography that everybody else uses for everything else, like TLS and email and whatever, because cryptography is really, really hard to get right. And so using standard algorithms usually is a safe bet. So with that, we get to naming systems on blockchains. And so there's a lot of those. And these blockchain naming systems, they all make their own rules. They can decide which names they allow. For example, some of them allow emoji domain names. They have their absolutely own rules. They are not connected to anything else. It's their system. They make the decisions. Often, if you look into it, they are not very well documented. Some of them are, most of them aren't. Uh, so resolution of blockchain names. So the biggest use case obviously is that you want to have a human readable identifier that resolves to your wallet address or your account address on the blockchain. Because these wallets or account addresses are usually very long strings that are not really human readable. And so the domain names give you an option to make that more user-friendly. And usually blockchain systems use domain names, or they use blockchain names in their own naming system, but they look like domain names. So they use the dot for separation of different parts. So, and that's what makes this so confusing, because they look like domain names, but they actually are a totally different system that is not connected to the DNS. Um, and so the names are stored on the chain. And on the chain, as we talked about earlier, every transaction is recorded on the chain, so they are public. So everybody can see every transaction. So you can always see which wallet controls which names, and you can always go back and see how, was there an owner change? Did the data change that is connected to the name? Everything is totally public and viewable for everybody. The only thing you can't know is the actual human behind the wallet, because there's no record of that. But the connection between the name and the wallet is always there. So if you think about the DNS has what we call the one root in ICANN that is called ICP3, where we say there's only one root zone and that's it. We run this one root zone. And back in the days, people tried to run other root zones, but that never got any traction. Uh, and you and think of it, it's the one root zone is a really convenient thing, because it means if we ask for a name in the DNS, we all know that we get to this one name that is controlled by this one entity. If we ask for Netflix.com, we always come to the domain that is controlled by Netflix, the American movie company, not by anybody else. Um, and that is obviously one of the things that the DNS can guarantee you, but that is not the case on blockchains, because on the blockchain, all these different systems work all absolutely independently of each other. So we have a lot of names that are not connected to the global DNS at all, and that don't even exist in the global DNS. So here on the slide, you see a few examples. .ease is the extension that is chosen by the Ethereum name system. But then there's some .wallet, .crypto, and these names actually exist on several of the blockchain name systems. So, and they are not connected. So a name on .wallet, like, let's say example.wallet, could very well belong to different people on different chains. And so if you try to transfer money from one account to the other and you write in example.wallet, you actually don't know where you end up, because it depends on which resolver you use. And depending on where you try to transfer the money, you could very well transfer it to a very different entity than you intended to. Um, and that is, these blockchains always think that, you use one resolver and that resolver does what you want, but it's really dependent on that you have the knowledge of what the resolver does. Otherwise, you even don't know that you end up where you want to end up. So and so this and then of course blockchains are not synced with the global DNS. So there could very well be in the next round that somebody applied for .wallet who is not running any of the current existing .wallets on any blockchain. So there would be a DNS.wallet, and then there would be different .wallets on all the blockchains. So there's no guarantee in any direction on this. There is actually some blockchains that allow you to import your current DNS names into the chain, but then usually you lose the connection between the DNS and the name on the chain. So then if there's an owner change in the DNS, that is not reflected that there would be at the same time an owner change on the chain. It could be very well that the old entity still controls the name on the chain, but a new entity controls it in the DNS. So there's really this is a really hard problem for all the chains to do this. Yes. And with that, just as a little side note, very recently, the IETF has released a new wallet, a new RR type for the DNS. Now we have a record type called wallet, and you can now attach different wallets to your domain name. It works actually, you can specify on which chain you want to attach which account number. So, yes. And with that, I have just one comment left, and that is, well, predictions are really hard, especially about the future. This will keep on changing, and keep watching this space. It will be a wild ride, but I think it will be quite interesting. And yeah, with that, I'm open for questions.
Thank you very much. So we have questions about this new technology that can interfere with domain names?
Yes. Yeah. So the thing is, for example, if you have there's web browsers, for example, Brave does this, who actually support chain names, domain names on blockchains. And depending on if a name has been imported to a chain, you could actually, your browser could actually go to a destination that is specified on the chain, but that is very different from the destination that is specified in the DNS. And so, for example, ENS allows you to import your domain name from any TLD in the world onto the Ethereum name service chain. And then your Brave browser would resolve this name to the Ethereum name service and get information from there. But if you have updated the information in the DNS, your browser wouldn't see it. And so this can very well influence your domain name in the real world. But, so you have to be really careful on these things, what you really do here.
Thank you. Could you just predict if all traditional domain names will transfer to convert into a blockchain domain or not? Is it possible?
Well, as I said, predictions are really, so as ICANN, obviously, we don't have any stand on this. So, but I can give you a personal view on this. So, and I would say currently blockchains are not capable of doing this. Blockchains are not fast enough for, the resolving on a blockchain wouldn't be fast enough for, for any type of DNS. I mean, the DNS is really, really, really fast. If your DNS answer is, 100 milliseconds, it is really, really slow. And I mean, Bitcoin takes 10 minutes for a new block to do. So getting answers out of the blockchain isn't really that easy. But that said, I mean, the future, if people set their mind to it, obviously we could improve this infrastructure to a point where it would be feasible to do this. But the question is, would we really want to? And I don't see that coming. I don't see that the blockchain is really that, a solution for a lot of problems that we have. There's solutions for some of the problems. I would say in financial services, I can see it become very successful, but in other parts, not so much. And I think the DNS is one where I would say not so much. But that said, there's obviously a use case for names on blockchains. And so I think there's some type of coexistence and synchronization will absolutely happen in the future, yes.
As I understand, in the next round of new GTLD, there will be several applications for blockchain domains for domains that based it on blockchain technology. As I know, the blockchain DNS technology developing very fast now. It's very popular topic to discuss in ICANN meeting and among domain specialists. mm,
Yes, as I can, no comment.
yes.
Obviously, you know, next round, people do whatever they want. They apply for whatever they want. I've heard too that blockchain companies are in the want to apply for new names. Yes, but you know, I wouldn't know. I'm not even involved in the program, so I have absolutely, you know, no knowledge about this.
Okay, so DNS and domain names serve a lot of things in our life. It's a web browser, it's email, it's communication, it's every application. But now we will see that domain names became some kind of money with this
Yes.
blockchain.
On the other hand, it's if you if you look at the blockchains, there's a lot of stuff going on. You know, people in the beginning, it was a lot that they made these names, and it was a lot about technology, and a lot of these block name companies that run these blockchain names have started to realize that the reason ICANN is there is not because we had problems with technology, but because we had problems with politics, you know, and we don't have to go to extremes, but let's say somebody wanted to register .Ukraine. Who would be illegal? Who would be allowed to do this? Only the Ukrainian government, or could that be some other entity? Um, I guess you wouldn't want some Russian entity to do it, obviously. I mean, but let's say somebody from the US wanted to do it. Maybe it's okay, but most probably you would like the .Ukraine to follow the rules of Ukraine. Somehow you would like it to be connected to your country for what, you know, in any way, but you want to make sure that it, you know, it's connected to your country. And that is just a very simple example. There's obviously you can start about, you know, different other names that are more politically more hard to solve, you know. And so people start to realize that it's not so much about technology, it's a lot about politics and who is allowed to do what. And that is something that is very new to the blockchain people. And I think that we will see a lot of development in this part.
As I remember in the beginning of the DNS, it's also, they are not technology, only technical stuff, technical things, but step by step it became more mature, and policy appeared, organization appeared who write the policy, who look at the issues that happened on DNS. Thank you very much. We have one more question from the audience, from Maxim Sirenko. Can it be that blockchain will serve as a distributed database for DNS in the future?
It could. I mean, if you look that today, for example, it exists that you have your name on Ethereum, and then there is actually a DNS service for Ethereum names. So they export all the names from the chain into a DNS server, and then you can actually look up your name in the DNS. They made the special arrangement with .link, I think. Some, you know, look it up. There is technology to do this. Absolutely. The problem is that, you know, then you have to believe it, and then maybe you have to do some DNSSEC on top of it, and then but who gets to control those DNSSEC keys? So there's a lot of questions around this, how to do this. That is absolutely not a solved technology, but there is some technology in beginning of a technology that allows to do this. Absolutely.
Thank you. Do you have any other questions? Також можна ставити питання українською, перекладемо. що блокчейн така дуже цікава технологія, і зараз домени на блокчейні розвиваються дуже швидко. Є багата кількість питань, спекуляцій, домислів щодо цього. Я думаю, що це цікаво. Так. So, no questions, I see. So thank you, Ulrich. It's a very interesting overview of this new technology. And I understand that you are going now to the webinars that Gabi said. And thank you very much for joining us and giving this information for us. Дуже дякую Ульриху за те, що він доєднався і розказав про цю нову технологію і як ICANN ставиться до цієї технології, як блокчейн-домени співіснують з традиційними доменними системами, традиційними доменами. Thank you, Ulrich. Thank you.
Thank you for having me.